Okay, sorry. Getting back to it. So if I am asking you to solve, I'm asking you to do what? Oh, quick reminder. Sorry, before I get back to that understanding check. Can you turn these things in late? Yes. If you need to get it done during enrichment, can you turn it in today without it being late? Yes. Right? So don't forget, take advantage of the time that you have. We shouldn't be waiting until today to get these graphic organizers done, because you should fill them out when we cover the term, so that they're fresh in your mind and you know exactly where to look. So be aware of that. But going back to the graphic or the understanding check, when I say solve, I'm asking you to find what makes the equation true. Which, what do we call the values that make the equation true?
Solution.
We want equivalent equations. They're called what again? Solutions, right? The solution is what makes the equation true, and we get that by creating equivalent equations. But students in first block, and I haven't looked over y'all's, but just glancing at first block, they very clearly forgot that what are you supposed to use to get you to know which properties of equality? Say again? The inverse, right? Remember, all you're doing is using the inverses to create the identities, right? You want to create those zeros and ones to then, and then with a property of equality to make sure that you have equivalent equations. You got to think about those kind of details. And I'll also point out those first four problems, they should look somewhat familiar. Where did you see problems like that, or where should you have seen problems like that? Say it one more time. Matthew. I didn't put a single problem on there that was not like problems you had on Matthew. If you were looking at those problems, you're like, yo, I got no clue what's going on. My guess is we didn't finish the Matthew work. Even if you did finish the Matthew work and you struggle with some of those questions, what could you do to get more practice in? You can review them. You can go back into Matthew and practice more. Again, they've got hints, they've got reminders. I will pause and I will want to say this. The quadratic one, number 3, how many solutions should you have had? 2. Good. Let some of us remember that. If you didn't remember that we needed 2 for that quadratic one, you need to go back into Matthew and practice those problems again. You've got to practice to get better. Alright? So please take advantage of that. Remember, you can probably go down to the library during your enrichment time or something like that. Just talk with your teachers so you can get those practice in, because the stuff in Matthew will be much more helpful than just doing paper copies, because it'll tell you when you get it right and wrong, things like that. Now, I do want to take a little bit more time to talk about the 2 equations. What type of functions were those last two problems?
Linear.
Linear? How do you know?
They added a constant change.
So they both had a constant additive rate of change. Now, the table, we saw the constant additive rate of change. How did we know that the graph was linear? It's quite literally a line, right? What is the first thing you should think about and the first thing you should write down once you realize it's a linear function? The slope-intercept form? So literally write down...
Why are you looking at
I would have started there. At least in first block, I saw a whole lot of people just trying to write the equation. Quit just writing the equation from the beginning. Write this down to help focus your attention. Show your steps and show your work. Even take a second to explain maybe why you think you need that equation. But once I get to this equation, that should be a huge reminder. Okay, so how am I going to get this m? Rise
Divided
by run. Now that's more useful for which representation?
The graph.
The graph, right? But for the graph, you might have written that. What about for the table? What would have been more useful?
Change in y over changing it.
Say that one more time.
Y divided by
Oh my gosh.
Change in y divided by the change in x, right? But it starts with that equation. Once you say, hey, it's linear, write that equation down, then write this down, and then figure out what the slope was. Because what I saw in first block was I saw a lot of students do the change in y as m, but then the change in x they put in for b. Should that change in x go in the place of b?
No.
Definitely not. But if you wrote this down, would that help prevent that mistake?
Yes.
Very much so. In first block, I already saw some students putting the change in x in the numerator and the change in y in the denominator. And they didn't write this down. Would this have helped make sure that they put the change in y in the numerator and change in x in the denominator?
Yes.
So write out your equations to get started. You gotta know those equations, but that's a couple of basics. And then the last detail, like on a graph, we should be able to identify the y-intercept pretty easily, right? Hopefully. If not, we need to get some practice with it. I'll make sure we have that soon. But if you have the table, how are you supposed to identify that y-intercept?
When x is 0.
Because what?
When x equals 0.
When the x is 0. That's always the y-intercept. Because any point on the y-axis has an x of 0. You got to know those things. Hopefully that's a quick little refresher. Hopefully we did a little bit better in here than we did in first block from what I've seen. I haven't scored them yet. Any questions about any of these details before we move forward? Yes, sir.
Can you go over for, like, the one where it's just variables?
I believe it was 1 divided by n times.
A plus
A plus B
B
sum.
Equals S.
Anybody have an idea what's the first thing I should or could do?
Distribute.
I could distribute. I wouldn't.
I divide. I divide
Say that
it.
one more time.
Divide.
N
1 multiplied by the
divided by 1. So please hear me very clearly. Can you distribute? Yes. Will it make your life harder? Yes.
Can you divide?
You could divide, but again, this is why I always talk about the reciprocal, right? Because the reciprocal is going to create that multiplicative inverse of 1. And so that all is now a 1, so I'm just left with a plus bx. What do I need to do to solve for a now? Say what? I don't need to divide by b.
Subtract bx.
Right,
Both
I'm trying to
sides.
solve for this a. What's happening to a is being added by bx, so I'm going to subtract bx. Notice I'm making you 0. Just 2 steps. Now, could you have distributed 100%? If you distribute, you get 1 divided by n a plus 1 divided by n bx, or you could even just put that in the numerator. But then you would have to subtract 1 divided by n bx to create a 0 there. And again, what are you going to have to do at this point? Reciprocal still, right? And I would have to multiply the whole right hand side by n. And what's s times n? I mean the same thing that I had right here. And then because those are reciprocals, those are going to create a 1. So I'm left with bx. Lots of ways to do it, but that's this first way is the most efficient. Yes, sir.
So is it wrong to still have 1 over n, like in your answer? Like a equals s, 1 over n minus b?
S divided by 1 divided by n.
I think.
So
I
you would have
I
had-
wrote it.
Like that.
Yeah.
It's not technically wrong, but we don't leave fractions within fractions. Which is why I emphasize the reciprocal so heavily. So like I won't let that be like a 6, maybe a 5, depending on how well you justify everything else. But that's why we use the reciprocal so that we're not left with a fraction inside of a fraction. Because, you know, to divide by a fraction, you just multiply by the reciprocal, which is what would have left you with that as well. Okay? Good question. I'll give feedback on student work though. To get us started with today, quick reminder, because we had an understanding check. And I know that's going to get frustrating for some of us because we're going to look at it and be like, yo, Mr. Kenny, I was not prepared for this. But it's okay. An understanding check, remember, is just to learn from. Let's say you learn from your mistakes after I give you feedback and you do better by the test. What's going to happen to your understanding check grade? If you do better by the test, it's going to go up by whatever you make on the test. Right? You could have made a 30 on this understanding check. You learn from your mistakes and you make, say, a 70 on the corresponding questions on the test. Well, then you have a 70 for the understanding check. You go from a 30 to 100, you have 100 for the understanding check, right? So don't be afraid of not getting it perfect this time around. Learn from your mistakes, grow, and get better. Because the whole thing is, what is math? Study of patterns and relationships, right? And you gotta notice patterns and relationships first, then you gotta describe them, and then you gotta generalize them, which is showing a progression as you get better with those patterns and relationships. So if you get better, I'm going to honor that. And I'm going to respect that, and I'm going to have your grades correspond to that. So be aware of that. Just learn from your mistakes, and that's okay. All right, we're going to finish up Lesson 2, Understanding Data and Context. If we finish it quickly enough, we will get to Lesson 3, the Dream Job Salary Task today. Now, I want to remind you, right, objectives. We're trying to use a calculator to identify an appropriate trend line to approximate data. We did that yesterday for the last task, right? What do we need to keep in mind in order to have an appropriate trend line? What's it got to do to that data? It's got to split it, right? It needs to show a trend, right? It's not just going to be like a vertical line that splits the data. It needs to be a line that is showing the trend in the data. If it's increasing, the data is increasing, we need to show that trend with the data. After we get a trend line, though, a whole really important component of it is we need to interpret key features. First off, what key features am I talking about?
X-intercept, Y-intercept, and slope.
Right? X-intercepts, Y-intercepts, and slopes. And whether you're talking about an X-intercept, a Y-intercept, or a slope, isn't the an X and a Y involved in all of those concepts? Right? Slope is the change in Y divided by the change in X. The Y-intercept has an X of 0, and then there's a Y value. An X-intercept has an X value, and the Y is 0. So if we're going to interpret the key features, we've got to pay attention to the context. We looked at this yesterday to establish a couple of details. I want you to pay attention to up here. You've got to pay attention to the writing in some sections to be able to get those variables. Because when we come to here, right, we should already have a linear model that your group already identified. And please note, even if you weren't here yesterday, or even if you didn't get an equation here, you should have an equation that your group has agreed upon. Right? I don't care what equation you have, you should have an equation that you all agree upon. Now, in order to interpret the slope that involves the change in Y divided by the change in X, in order to interpret the Y-intercept, right, what do we have to do first? Define the input and the output. I need you to hear me very clearly on this, because this is what students in first block did not do, and then they got frustrated, was they did not pay attention to the variables. Because all that is happening is you are taking the number from your equation and you are pairing it with the definition for that variable. Don't make it more complicated than that. So what is the first thing we always have to do when dealing with data? Define those variables. I'm going to give you all about 4 or 5 minutes within your small groups to make sure that you as a group have come up with a definition for your variable. Now pause and listen. I need you to focus on this, okay? If you finish that, you're not going to sit there and do nothing. You're going to move on, right?
Move on.
Now, I need you to hear me very clearly on this as well, though. All right? When it comes to defining these variables and paying attention to everything else, yes, the graph can help you because there's important details on the graph. That's why I sent the file back out to you. But you have to read a little bit here. Go into detail with your variables. And hopefully, you as a group are going to come up with a consensus, right?
Right.
Which means that you as a group need to be what, Jesus? Working together. So I need you to focus here so that you all are prepared to talk as a group, okay? Listen, you've got to talk with each other. And a student in first block said, hey, but Mr. Kinney, I feel like all I'm doing is looking back at task 2, like especially when she got down to slope and Y-intercept. I'm just looking back at task 2 and then rewriting it here. Guys, that's how you learn. You take what you've done in the past and apply it on your own instead of having me have to tell you how to do it. So use your resources. Go back and look at the previous problem because this problem is completely different. But if you can use your previous problem to help you on this one, then you're learning and you're growing. If you are talking with people in your group, you're going to either figure out, hey, I understand what's going on, or hey, I have a misconception, so I need to fix it. The talking is where the most learning happens. The person who talks the most learns the most. Students in first block overall today, I would say about half the students did a great job when we had whole class discussion and talking. However, almost no one earned a 4 on the active collaboration rubric. Any guesses why? They weren't talking in their groups. You have to take the initiative to ask questions of those in your group. If you feel like you understand what's going on, say, hey, right? So if it's more, hey Chloe, what were you thinking about this? Or this is what I was thinking, what do you think about my ideas? You have to take the initiative. If you don't have a clue what's going on, awesome. Ask someone in the group, hey, Tracy, I got no clue what's going on. Can you help me out here? When we start dialoguing, when we start talking, you're going to learn more. Because you know what is required in order to talk? You have to use your brain, you have to think. When you talk, it's going to require you to think. And you're going to learn as a result. So please, talk with each other, help each other out. So, 4 to 5 minutes. Use your calculators, use the context to figure out what these variables mean, completely in their entirety, and then move through the rest of the problems. Sound good? And break. And by break, I mean go. Before you start getting into that, have you all actually checked in with each other to make sure you all have the same things written down for the inputs and outputs? Have you? The same equation. I do recommend that you have the same equation because then that way you can talk with each other when it comes to the slope and line intercept. My point is here, you have significantly more written down than he has. Is that all you wrote? What was you write? Is all of that important for the X? So you're agreeing with them, right? So you see how like they're both thinking that, so that might be part of an important idea, right? Because here's the thing, if I had the year 1950, am I going to substitute 1950 in for X?
Well, you ain't getting nothing on this one.
By there, well, John's answer to that. What am I going to substitute in for X? If it's the years since 1900, it's always X.
Whose equation?
It's the years since 1900. So is it important that we include the idea of years since 1900?
Better than yours.
No.
Mine, you
Now,
know some.
I'll say this, you need to go back, go back and
It's supposed
output,
to
look
get
at
that
the
information.
information.
So mine is going. It's supposed to split them. Supposed to split them evenly. That's what it means.
It's not gonna be.
Mine is more even than yours.
Is it really? Count that.
That would be ideal, just because it'll help you when working on the slope and the y-intercept and have exactly the same numbers.
Mine.
Now, we'll say
To ask around a
perfect,
Yeah, we
a
gonna-
little
we
bit
gonna
more
do
detail that you're forgetting. Go back up here. There's an important
I just told
detail
you
that you're
that.
missing about
That's how. Just look at ours.
cars. I want you to think about this. You see that line right here? On the x-axis, the y value is
I
what?
think it's more of
Zero. So by this, you're saying that the Earth's temperature during that time was 0 degrees Fahrenheit.
It doesn't matter for real. It actually doesn't matter. We check on you.
So go back up to here, there's an important idea about the temperature.
like yours. I really
You
don't
like
care, I'm
both
just
those numbers
trolling.
being
We gonna
intersected.
use mine.
Don't erase it all, look to see if you can find extra information.
We're gonna do mine because of me. Okay, so what's the actual?
What's the equation mean? Come
Just to
on.
clarify, don't forget, when we say x-axis, we're talking about this right here.
Equals.
So we're not talking about the x-axis, we're talking about the x variable,
And then X minus
right?
one.
The y-axis is this line on the graph.
Dude, I got
So that's not a y-axis, it's a y
Did you
variable.
give her? Right, I got 2, y'all
Yeah, they
can't
should
one
not.
point. See, they don't know what they doing. I
Why
can
did you do that?
You got it. It started with 0.
Why
Didn't
did you
it?
see it?
Yeah. Yeah.
Um,
We talking about the Y.
So what's the wild?
Come on now.
Okay, now. Does it have to be budget? Like, does it have to be budget?
If y'all is easy, why y'all ain't say that?
Yeah, my equation is easy, right?
Why you ain't say that?
No, we have to do it 3 times.
Why you just ain't say that?
Alright, bro, come on. Because the input variable represent what the
Are we doing yours or
X.
closing?
Bro, we are not.
I don't even remember mine.
I had the easy ones that ain't speak up.
Is it,
Come on.
Nah, we
is
ain't.
it increasing or
You
decreasing?
just write something.
The f of x represents the centuries,
Oh, I
and
don't know
the
what we
input represents the temperature.
Well, yeah.
I
So
want you
as
to look
the
back at
years
your calculator.
pass,
Everybody look at their
each
calculator.
year, because we're counting by one.
Does anyone see in the calculator how I could identify x and y? Looking at that graph.
That way, positive.
I think it's like that. She just had to erase the
Exact connection. So also,
It says, there's like a little label.
There is a little label, bottom right hand corner.
I'm trying to say.
What does it say the
where it
x
crosses
is?
the y-axis.
Years since
So
1900.
I just looked at,
Oh.
at
Huh?
years,
And then after,
like in 1900,
Okay, but you
the
put
average
temperature
was
in the input.
low.
Put in the output.
the way you gotta add context.
Oh, years are independent of temperature, that's not what.
Yes, and you actually know how much it's increased by each year.
There's a little bit more to it than just temperature. Look at your context. Earth.
Point zero.
Thank you. Thank you, thank you. Okay, I'll go ahead and tell you, the input, that's the easy one in this case. I think majority of students got this right or got close to this. Now, I want to emphasize a detail. The input variable, which letter are we using to represent the input variable?
X.
X, okay, so we want to keep that in mind, because when I have an equation, which most of you should have an equation, you need to know this is what X represents, right? So Jakeem, what did you originally write down? Not where you are now, but what did you originally write down for the input variable? X equals the years, right? Now, that's a great mistake to make. I love it. What's the mistake with this?
There's no context.
I mean, years is context.
It's not very specific.
It's not very specific, so let me also point this out. This is how I approach it in this group, and you want to pay attention to this from one of the later questions. If I were to say I'm looking at the year 1950, am I actually going to substitute 1950 in for X? No, what would I substitute in for X? 50. Why is it 50 if the X is years?
Because it's years since 1900.
Notice it's the years since
1900.
1900. Notice how you can see the y-axis on that graph, correct? What do you know the x value is on the y-axis? Oh, the x is 0. And with an x of 0, you're literally talking about what year? 1900. So it's not enough to just put your units, you got to pay attention to everything within those units. Right? And that's why it's important to say years since 1900. So if we had 1950, right, so this is for an example. So if you want to write this example down, you can say x equals 50 for 1950, right? That's why we have to say years since 1900. That changes things. You good with that idea? Anybody got any questions about that? Are we comfy with that idea?
So if you put like year 2000, you put 100.
What do y'all think? Year 2000, would x be 100?
Yes.
Yes. Perfect, right? That's what we want to recognize. Good. Now, I do want to emphasize, because I saw some people who did have their variables flipped, how should we have known that x was the year since 1900? It's on the calculator, isn't it? Inside the parentheses, like if you look at your calculator and you look at, come on, we have it on the right page, 3.2. If you look at 3.2, what does it have in the spot for x?
Years since 1900.
Years since 1900. And it's right there, right? It's not even just years, it's years since 1900. It tells us that. Now, for the output then, which letter are we going to use for output?
Y.
F of
Y.
X or Y.
Okay, but I want to point out, what do we have in the equation?
F of X.
F of x, right? So we do want to remember that y and f of x our outputs, right? But in our equation, we have f of x, right? So f of x is our output in this case. And so, what does it say on the calculator?
Earth temp.
Earth temp? But that's not fully right. And I saw some students kind of thinking that the output was just the temperature of Earth. Does anyone know, well, it's part of it, but does anyone know why that's not completely correct?
Because it's not specifying the type of temperature. Like
Okay, we do need degrees Fahrenheit, don't we?
Yep.
So that's part of it, but there's actually a bigger issue at play. Escape that, bring this up. Sorry, I should have already pulled this up on the document. So here's 3.2. Remember, zoom to our data. There it is. Okay. So I want you to look at this graph right here. This data point has roughly a y value of 0, correct?
Great.
Or if we say Earth temp, that'd be 0 degrees Fahrenheit. So I want y'all to think about it. Has the Earth's overall temperature ever been 0 degrees Fahrenheit in the last 100 years?
No.
Oh, so that can't just be Earth's temp, can it? Oh.
The average.
Say that one more time?
The average.
Oh, there's something about an average with the Earth's temp?
Yep.
So, the hint of Earth's temp is super important, but go back to the context here. It wasn't just Earth's temp. If you look right here, data has been recorded every year since the start of the 20th century. Each data point represents the number of years since 1900. There's my input, right? That's what we said was the input. And is that just Earth's temperature? No. It's not just an average. If I have 20, 1.5, that is 20 what? It's 1920 because it's 20 years since 1900. 1.5 what? It's not just the average. 1.5 degrees Fahrenheit
Above or below?
above the average temperature from 1900 to 2000. Notice how we have to have that full context. Notice it's there though, but if you don't put this number with the entire context, it all goes confusing. It doesn't make a ton of sense because again, it's not 1.5 isn't the average, it's 1.5 degrees above the average. You got it? Thank you. So when we are looking at this page here, is it enough to just say Earth temp?
No.
No.
Okay, so how would I need to talk about this output? This is the,
Average.
go back to the beginning of the sentence. Like we're trying to remember it all off the top of our head instead of look at what it actually says. What does it actually say? I thought it said temperatures are in degrees Fahrenheit. Okay, that's what we have to go back to. Does it involve the average? Yes. But literally, it says and, so these are temperatures, right, in degrees Fahrenheit. But what about those temperatures? They are,
Average.
before that,
Below.
so above or below.
The average temperature.
Okay, we need a little bit more detail than that though.
From 1900 to 2000.
Right, because is the average temperature from 1900 to 2000 the same as 2000 to 2100?
No.
Is that going to be the same as 700 AD to 800 AD?
No.
No. So we need to be clear or below the average temperature from 1900 to 2000. Have you ever had to pay attention to that level of detail before?
Nope.
Which is why this is uncomfy at first. I need you to hear me very clearly. I understand that it's uncomfy. However, it is that attention to detail that's going to make this math make sense. We've gotta understand understand the math in its full context. Now, just like a second ago when I talked about 20 and 1.5, again, that 20 is my x, correct? Yes, sir.
Yeah, talk to me. Keep
Okay,
going.
cool. Okay, that 20 is my x, so 20 what? Say it again, Keyshawn. 20 years since 1900. Literally, I took the number and I paired it with the context. I can't just say years. I gotta say years since 1900. Well, 20 years since 1900, 1.5 what? Degrees Fahrenheit above the average. See, I read the whole thing? Now, Momo, I got an important question for you. Why is it above and not below? Why did we skip the below?
Because it's not negative.
Because it's not negative, right? The fact that it's positive tells me it's above. But literally, I just take the numbers and I pair it with the context. Which is why, what is the first thing you have to do with data? You gotta define those variables, right? If you don't define your variables, the numbers don't make sense. And the numbers are supposed to make sense. Alright, now, you should already have, hopefully your slope written down there. You should already hopefully have your y-intercept. Work within your small groups. Use your context and your variables to figure out what the slope represents, what the y-intercept represents. Get done with those, move on to the rest. And we are talking to help each other grow and learn. Any questions?
Y'all ready?
Let's get to work. Yes, sir.
Let's go.
Yeah.
For me,
Are you relying on it?
I gotta get caught up somehow.
Well, you need to go back to this based on how we fully define it. Right, there's a little bit more you want to add. But what is your y-intercept?
So what is,
Black king.
Negative 0.4. Is that the entire y-intercept? I think we said that we covered the y-intercept earlier. What do you know about every y-intercept on ECA? On ECA, what did he say that we need to know about every y-intercept? The x is what?
Okay, but we done, so now we gotta go to what the context.
Okay.
Ain't that's the.
Hold on, let's come and check that in a second. Come on, I need everyone to pay attention to this. What, I need y'all to listen. What do we know about every y-intercept?
Our stuff look the same to me.
Well, it's the same, but it's not the same.
The y-intercept is what?
Slope with the one with the egg.
Come on, Caleb said it
Okay, so we
earlier. The x is equal to 0, right? So you can't just put negative 0.84 as your y-intercept. The x is equal to 0.
Okay.
Now, go back to your context. You have an x and you have a y. So tell me 0 what? Negative 0.84. Not just below temperature, below what temperature? Below the average temperature, right? You gotta go back to that context. Are you there, Jake? Huh? I know, but like just